snowflake really, really close? Well, if you have, then you might notice its intricate hexagonal arms branching out symmetrically in the 6 points. Keep going on, and the snowflakes shrink more and more till one point where you can't even see them. Or maybe a new leaf, which replicates such complex patterns without any errors. Even fancy paintings like the Mona Lisa and the Great Wave follow this algorithm. And then, what is this seemingly almighty shape everywhere? Well, after a couple of sleepless nights and quite a few articles of research, I finally got the answer. That may just shock you. Well, the culprit is called a fractal. The word was coined in 1975 and is derived from the Latin word fractus, meaning fractured or broken. Essentially, they were patterns that could not be fractured, but as mentioned, broken. Wait, pause. How did this all start? Well, it was a hot summer's day as I sat on the ground floor of the small apartment I used to live in at the time. And as I watched my cycle prepare to leave from the playground, I noticed something fluttering in the light out of the corner of my eye. It was a spider's web. A voice rang through my head. A spider's web can support a lot of weight. Yet, every time I walk through one, it cracks. The last time I checked, I'm no weightlifter. Well then, what is the secret at work here? Here comes the technical use of fractal. Due to the ever-repeating patterns, there are seemingly infinite layers of support created, making the web like a giant mesh of sorts, and in theory, unbreakable. Indeed, this pattern is so useful that many architects use the structure in their buildings to provide a safe and sound place to develop. And though a spider's web is the checklist for being a fractal, it isn't a mathematically accurate one, since it moreover relies on tension dispersion. Scientist Richard Taylor from the University of Oregon, psychologist Michael S. Burbid from the University of California in Berkeley, and Professor Eleanor Gibson, a Harvard major in psychology, along with their teams, have proven that this kind of pattern sparks a sense of satisfaction in the minds of the human. For those of you who adore reading about dystopian futures, there seems to be a silver lining between these unstoppable forces that hunt down our favorite characters and the kind of robot dogs that we can rescue. For the ones of you who don't read books and have your noses stuck in a phone all day, the robots can essentially scale any wall and take any fall, while the most noticeable feat of the dog is doing a backflip. And as such, the query seems clear. What is the difference between their and our efficiency? Well, what if I told you the secret is the very same thing that lets you watch your favorite TV show and keeps it scrolling on your mobile phone, and you have it right now. Fractals get their primary use in antenna, which provide, you guessed it, signals. Fractals are the pinnacles of crossroads between the worlds of software development and engineering. Or for the adventurous ones of you, tracking the antenna of a robot is like naked deaf and blind. And such is proven by a esteemed innovator, Nathan Cohen, a radio astronomer and physicist, founder and CEO of Fractal Antenna Systems. Well, sorry the robots have to talk back, don't they? Well, fractals are great here as well, since the similar properties are a key development in the worlds of decoding and encrypting. For example, one C on the middle octave can be altered to sound higher or lower, while two different C's on two different octaves can be pitched to sound roughly the same. Well, how do the robots make sure that their signals go to the correct robot and not a random child playing in the backyard. Well, fractals are great here as well, since they use something called beamforming. This practice prevents a lot of wastage when it comes to invisible waves like sound and light by using a direct beam instead of, let's say, a continuously expanding speed. Think shining a lantern versus using a flashlight. Though the lantern may give you more coverage, it very lightly illuminates everything around you, while the flashlight will help you pinpoint what you're trying to look at. Pretty cool, if you ask me. Some common appliances in your house that use fractals include your mobile phone, your TV, a microwave, and pretty much anything that needs a screen or needs electricity. Possible. In colder countries than ours, like Russia and Canada, people use fractals in the pods to help the heat disperse faster. And the best part is that fractals require less material, inevitably meaning less cost. So the next time you look at something, remember that there is probably a fractal at work somewhere in there, and for all we know, it could be the one to change the world. Thank you.